Okay, hello, it's FY here. So now we're going to continue with the improper integrals of type number 2. Where type number 2, you will not see an infinity on the integration itself, but we will see some number. But when you see the interval of the integration, some number, then you have to be careful with that. Okay, so let's just look at the definition first, okay, of the improper integration. Okay, so for this we have here, okay, so what we have here is you have a function f. Okay, so look at the a first. Okay, so in a, okay, what we have here is we have the f is continuous from a to b. Okay, and it is included a, but it is actually excluded, okay, do not include it to b. Okay, so you have a picture like this. Okay, so when the function f is actually does not continuous, or we say it is continuous at b, then we have to use the formula of this one. Okay, so what you have to do is you have to sub the one that give you a problem, okay, to t. Okay, so in this case what we have here is actually the b is discontinuous. Okay, so that's why we have to change the b here. So you have to change the b here, so you have to sub the b, okay, with the t. Alright, okay, and what you have to do is we're going to use the same concept. We're going to put the limit in front of it. Okay, so t approach to b, but be careful with the b here. So now you will have a left limit. Okay, well, because you look at the region, so the regions is actually at the left hand side, so that's why you approach to b, but this b is actually in terms of left limit. Okay, so let's just look at the second type that you will see here. Okay, so now we have another case, which is you are having a function f which is continuous from a to b also, but the a is actually excluded, just like these pictures, excluded. Okay, and it is included to b, just like these pictures. Okay, so the one that give you a problem is actually a. So the function is actually do not continuous, or we say that discontinuous at a. So you have to change the one that give you problem with the t. So in here you change it to t. So the limit will be t approach to a. But look at the region. The region is actually that you have here is actually on the right. So it's actually approaching, okay, from the right hand side. So that's why we have here this is a positive. Okay, the approaching from the right. Okay, so this is supposed to be a t approach to a from the right. Okay, so this is a plus. Okay, to be simple, just remember. Okay, whatever on the top. Okay, just to be simple. So whenever you have something that you want to substitute, which is on the top, so you change it, whatever on the top. Okay, so you're going to use from the left limit. Okay, and whenever you're going to change something, that is on the bottom, we'll change this one. So you're going to use from the right, positive. Okay, so then the conclusion for this integration will be the same as the previous step. And whenever you are able to find a finite number, we say that okay, the limit exists, and they are convergent. But when you are unable to find a finite number, we say that the limit does not exist and they are divergent. Okay, so let's just look at the example one directly. Okay, basically the question will not tell you that the function is discontinuous at which point. Okay, you have to analyze the function by yourself. Okay, so let's look at the function that we have here. Okay, so you have 1 over x, let's set x minus 2. So the choice that you have is only 2. Okay, that is from 2 to 5. Okay, so you have to think which number will give you a problem when you substitute in here. Okay, so of course you have an option of 2 and another option is 5. Okay, we will sub 5 in here. So we have 5 minus 2 is sub 3. So sub 3, 1 over sub 3 does not give us any problem. So that is acceptable as an answer. The one that will give you problem is basically the 2. Okay, so let's say if you sub, let's just say if we sub the x as 2 here. So you will have 2 minus 2, okay? So this basically 1 over 0, 1 over 0 will give you a problem. So that's why we will say that this one, this function is basically discontinuous. Discontinuous when the x is actually equal to 2 because the 2 will give you a problem, okay? So this function is basically discontinuous at x equal to 2. So this integration is actually under the improper. Okay. So this is integral is improper. Okay. So now let's just copy back the questions. So we have 5, 2, okay, so just now we say that, okay, the one that gave you problem is actually the number 2 itself, okay, because it's discontinuous at there. So, according to the definitions, the one that gave you problem that you should sub it with t, and you should do the substitution, sub it with t, so we will do limit, and t approach to 2. Alright, okay, we define the from the left or the right later, okay. So in here, so you will have t here, okay, the rest we're going to write it back, so we have 5, and then that is what we have, okay. And okay, this region is basically on the right, okay. So this is actually positive, okay, or you can follow the definitions. Okay, the one that you change on the bottom should be positive, okay, which is from the right hand side. Okay, so once you have substitute, okay, what I did here is I just substitute 2, okay, with the t, okay, so we put the same concept, we have a limit t approach to 2, but this 2 is from the right, okay, we have a plus there. Okay, so the next things that we're going to do is we're going to do the integration, okay, and for this case, of course, you have to manipulate it in order for you to integrate, so you have to use the concept of calculus 1, so we're going to sub this one as u. So we have the du dx here. So copy back the limit. Okay. So in here we will have, okay, ignore the reference. Okay. So in here we will have this one is 1 over. Okay, this is the u. So we have u here, and this du. We change it to a form that is more easier for us to do the integration. So basically this is actually u minus 1 over 2 du. Okay, and of course it's very easy for us to do the integration. This is actually equals to u 1 over 2 over 1 over 2. Okay, and this is actually 2u 1 over 2. Okay, so okay, try to sub the u back. Okay, so substitute the u back. So what is the u here? The u here is actually x minus 2. We have the 1 over 2 here. Okay, so now everything are in x. Okay, so to put back our interval that is t from t to 5, from t to 5. Put it back. Okay, so again we're going to repeat the same process that what we did in the type number 1. So we do substitution. So here we will have 2. So we have 5 minus 2 over 2 minus 2 t minus 2 over 2 here. Alright, okay. So let's simplify it. So when you simplify it, we will have 2, 3, 1 over 2. And this will be the same thing. This will be the same thing, okay. Okay, we can give the limit to both, okay. And let's just rewrite back the limit. Oh, okay, because this does not have t anymore, we can just give the limit to the one that have t. So this is actually still 2. The number doesn't have any effect with the limits, okay. So this is still set. And we can write it back to another form. We have a set 3 here, okay, and write this limit to this next to this terms. So this is 2, okay, this is a set, this is set, so t minus 2, okay. So let's just see what happened now if we do the substitution. So we have 2 set, okay, to sub this one with a 2 here. Oh. 2 here, okay, and a minus with 2. So 2 minus 2 will basically give you a 0. Okay, so 2 set 0 is actually 0. So at the end we have an answer of 2 set 3 only, right? So this is the final answer. And because you are able to find the answer in terms of finite number, this is number. So we say that actually limit exists, and it is a case of convergence.